Today's lesson is on surface area of prisms and cylinders. First of all, we need to discuss what a prism is. A prism is a three-dimensional shape. That three-dimensional shape has two bases to it. So in this diagram down here in the middle, you can see that the bases are represented by rectangles. But these two bases can really be almost any type of polygon that you desire. They could be trapezoids, they could be triangles, they could be hexagons. Really, any shape that you desire can be the bases, as long as it's a complete polygon. Now, when we name these prisms, we might call it a hexagonal prism. That means the bases of that prism are hexagons, and the lateral sides, which is what we have over here in blue, are always going to be rectangular in shape. That's how you can tell the difference between the bases and the lateral sides, is that the bases are always parallel to each other. You have, for example, one on the top, one on the bottom. You may have a left side or a right side to the base, or a front and the back be the bases. But you can tell the bases because they are a unique shape, where the lateral sides are always rectangular in shape for prisms. So when we talk about finding the surface area of a prism, what we have to do is we got to think of the different parts that are involved here. So to find surface area, we're going to take the area of the bases. Now in prisms, the bases are always going to be congruent to each other. So we're going to say we're going to take 2 times a capital B. That capital B is the area of the base. And that's the area of the base of that prism. Now, you might be finding the area of a hexagon, a triangle, a square, a trapezoid. It could look like a plus sign, for instance. A plus sign is a polygon. It could be any type of base that exists within that polygon. And then what we're going to do to that is we're going to add to that the area of the lateral area, the area of that rectangular shape that goes around the outside, or the blue portion of our prism. Now that rectangle, the base of that rectangle is represented by P. The P stands for the perimeter of the base. And then there is an H back here underneath my drawing, and that H stands for the height of the prism. Now the height of the prism is always the perpendicular height from base to base. So being that that's a rectangle, we can find the lateral area by taking the perimeter of the base times the height. So this is the formula for the surface area. It's 2 times the area of the base plus the lateral area. That requires that you also find the lateral area, which is found by taking the perimeter of the base times the height. And we'll demonstrate this in a whole bunch of examples coming up here in a minute. The second shape that we're going to talk about today is cylinders. Cylinders fits in with prisms because the only difference between a cylinder and a prism is the bases are circles. That is really the only difference between a prism and a base. You have 2 bases that are circles. You got the top here, and there would be a bottom one here. And you have a lateral area, which is like the soup can label, which is a rectangle in shape. So it's a lot of the same characteristics, but one has a polygon as a base. The prisms have polygons as bases. Cylinders have circles as a base. The only reason we differentiate between the two is because the circle is not a polygon, so it kind of gets its own category. So to find the surface area of a cylinder, we're going to do the same setup here, but we're going to substitute some pieces in. So surface area of a prism, being that it was so similar to a cylinder, is 2 times the area of the base. Oh, let me clean that up a hair. 2 times the area of the base plus the lateral area. Now, being that we're talking about a cylinder, the area of the base is the area of a circle, which is symbolized by pi r squared. The lateral area, we got to do our rectangle, which is length times height, or base times height. The base of the soup can label is the circumference of the circle, which is where the 2 pi r comes in. So we're going to take this plus 2 pi r times the height of the prism, which is h. And this is the formula that we're going to use for the surface area of a cylinder. If we need a lateral area of a cylinder, that is just the end portion here. So to finish off our formulas, our lateral area for a cylinder would be 2 pi r, the circumference of the circle, times the height of the cylinder, which is the distance from circle to circle. To summarize our formulas, for prisms, we may be asked for the lateral area, which is that area around the edge, around the lateral sides or the lateral faces of the prism, not including the bases, and that when we unfold it, it makes a rectangle. So to find that, we would take the perimeter of the base and times that by the height of the prism. For the surface area, we have to take the lateral area and then add to it the 2 bases. So we have 2 times the area of the base plus your lateral area. You may see this written like this. Surface area equals 2 times the area of the base plus perimeter times height. All I did there is actually substitute in the perimeter times height for the lateral area. I'll probably end up showing you that more than anything because that's more of what I've done in the past. For cylinders, your lateral area formula was 2 pi r times h. The 2 pi r is from the circumference of the circle. The capital H is the height of the cylinder. And then your surface area is 2 times the area of the base, which is 2 times the area of a circle, pi r squared, plus the lateral area, which was 2 pi r h. Now, what I would do if I were in your shoes right now is I would take and pause this video, and I would write these formulas down so that you have them handy. These are on your formula sheet that you'll be supplied with on the test and for the homework assignments, but not a bad thing to have written down at a nice convenient spot in your notebook. So moving on, what we're going to do is we're going to look at some sample problems here. In our first problem here, you can tell these are directly from our Moodle assignment. What we're going to do is we're going to find the surface area. That's important that you know what you're looking for. We have the surface area of this object, and we're going to round to the nearest tenth. Now, when you have what I call a box, It's just a generic rectangular prism because the bases are rectangles. There's no definite bases to a rectangular prism. It could be the top and the bottom. It could be it could be the bottom and the top here, if I like. I could look at it where the left side and the right side are my bases, if I like. Or I could look at it where the back and the front, that's pretty hard to see there on this drawing, but the back and the front are your bases. It really doesn't matter which ones you choose to be your bases, but you kind of have to designate that before you get started here. My rule that I usually use on a rectangular prism is I always default to top and bottom being my bases if I have a choice. Just because growing up at the younger levels, you look at the top and the bottom as your bases generally when you're looking at a box. So those are going to be my two bases. I'm going to start off by writing out my formula. Surface area of a prism is 2 times the area of the bases plus the perimeter of the base times the height. So to start off with, the first piece that I'm missing is the area of the base. The base is a rectangle, so I need to find the area. Area of a rectangle is base times height. So that would be 18 times 6, which gives me 108. So now I can substitute in that piece. Surface area is 2 times 108 plus my next piece that I need is the perimeter of the base. So looking at perimeter of the base, this distance here is 18 plus 6 plus 18 plus 6. So if I calculate that out, that gives me a perimeter 18 plus 6, and I simply added those up and multiplied it by 2 because there's 2 18s and 2 6s. That gave me a perimeter of 48. So I would go ahead and substitute that in for the location for the perimeter of the base. Our next piece is the height. Remember that the height is your distance from base to base. So our distance from base to base on this prism is 8. So we would substitute in the 8 there. The rest of this is simple calculations. You can type this in as it looks on your calculator if you need. So 2 times 108 plus 48 times 8. That gives me a surface area of 600. Because this is an area, we would use square units. Now when you type this into your Moodle assignment, it's not looking for the units. If you type the units in, it's going to reject it and make it a wrong answer. So I would stick with the 600. Now notice up here it said round to the nearest tenth. There is no decimal here, so I don't have to worry about that. I would just leave that alone. Here's our next problem. We got a surface area problem here again. It says find the surface area of the following prism. First thing I would do is write down the surface area formula. 2 times the area of the base plus perimeter times the height of the prism. Now this one is a little bit different looking. You notice here you have 2 triangles. It's a triangular prism. The deal with the triangular prism is that your bases have to be the triangles. So we have a base here and we have a base back here. Those 2 bases are congruent to each other. What that means is that the 15 is actually your height of your prism. Now that looks a little awkward to most students right away because it's not standing upright where the top and the bottom are the bases. This object is actually laying on its side. And think about it this way. If you're laying down on the floor, you're laying in bed, your height hasn't changed. Even though you might only be 12 inches tall when you look at the floor up to the top of your toes or whatever you're measuring, but your height, it stays the same. If you're 5'6", when you lay down, you're still 5'6" as far as your height goes. You're just not standing upright. So this object is not standing upright. That needs to be perfectly clear. So the area of a triangle is 1/2 base times height. Now, looking at what we have here for this triangle, we got 8, 8, and 8 for the three sides of our triangle. That tells me that it's an equilateral triangle. From our last unit, we learned that the nice thing about equilateral triangles is they break up to 30, 60, 90 triangles. So if we have a side length here of 8, this partial side here is 4, and the height of the triangle is 4 square root of 3. So when we calculate this, the area of our base is 1/2 the base, which is 8. Please remember, you got to go from one side of the triangle all the way to the other side. The 4 is only halfway. The 4 is used to help you get the height. The true base of that triangle is a length of 8. You multiply that times the height, and that's an ugly looking H right there, so I'm going to clean that up a little bit. The height of this is 4 root 3. So now I'm just going to multiply together what I can. I don't want to type this in and get a decimal and then use the decimal for further calculations, because that's going to create some inaccuracies. I can simply figure this part out right here and add the square root of 3 at the end and save that square root of 3 for my final calculation. That'll help keep my answer as accurate as possible. 1/2 of 8 is 4. 4 times 4 is 16. So I'm going to put my area of the triangle at 16 square root 3 for right now. So we can go ahead and plug that in here. Surface area is 2 times 16 square root 3 plus, now I need the perimeter of my base. The perimeter of the base, we remember our base was an 8 by 8 by 8 triangle, so 8 times 3 is 24. So the perimeter of my base was 24. And now I need my height. We talked about this already. Our object is laying down on its side, so the height of this is 15. So now if I type this in, I'll pull up a calculator here so you can see me type it in. So I would go 2 times 16 times the square root of 3. Now I have to use this right arrow key to get out of the square root. If that square root continues on with the rest of what I'm typing in, you're going to get a bad answer. You don't want that. So then we hit that right arrow to get out of there. We add 24 times 15. And we get our answer, which is 415.43. Now it said to round to the nearest tenth. Remember, 10 has 1 0 to it, which means we're going to do 1 decimal place. We need that 3 to tell us, are we rounding up or are we rounding off? And we are rounding off in this case. So my final answer when I go to type this one in would be 415.4. And then this would be square inches if I were writing my answer out on a test. Here's a third example. This third example here, we're still looking at surface area. So we're going to start off with our formula, 2 times the area of the base plus the perimeter of the base times the height. We're looking here at this object, and we need to identify what the bases are. This prism here, again, is a triangular prism, but this time your triangular base is not an equilateral triangle, but instead it's a right triangle. So we're going to keep that in mind as we try to find our missing parts here. So we're going to start by looking at what we need to plug in. Area of the base comes first. So that's 1/2 base times height. Nice thing about right triangles, especially when you have both little legs, is one leg is the base, the other leg's the height. It doesn't matter which is which, but you're going to use them both. So your area is 1/2 6 times 9. And half of 6 times 9 gives us an area of 27. Go ahead and throw the 27 in there for the area of our base. We're going to add to that. We need to find the perimeter of the base. Now here's where it gets a little bit tricky, not too bad. We got our 6 here, we have our 9 here. We do not know what the hypotenuse of that right triangle is. So what you might have to do is you might have to resort back to Pythagorean theorem. A squared plus b squared equals c squared to get that hypotenuse length. So that would be 6 squared plus 9 squared equals c squared. 36 plus 81 equals c squared. If we add that up, little brain freeze right now. So 7. So 117 equals c squared. Apologize for freezing up on that one. We would square root that. Now, I'm going to use this answer. I don't want to round it off yet. I want to save my rounding until the very final step. So that c value is square root of 117. So for that perimeter, my perimeter is going to be 6 plus 9 plus that square root of 117. I'm going to show you how I'm going to type that in and keep my rounding to a minimum here in a second. Let's just grab the height to finish off this equation right here. So our height here, again, we got our triangle in the front, our triangle in the back, which means the 10 is our height, because that's the distance from base to base. Again, this triangular prism is laying on its side, which puts our height at 10. Now, let's go back and put that perimeter in here, and let's look at how this is going to look on the calculator. So I'll clear out my old work. We said we had 6 plus 9 plus the square root of 117. Oops, let's type that in correctly. All right, so that gives us a ballpark figure of 25.82. I'm going to just write it in like that, but I'm not going to type it in like that. I already have that in my calculator right here. So what I'm going to do is I'm going to use the features of this calculator to help type it in and not round off until my very last step. So I'm going to go 2 times 27 plus. I need that previous answer. So one way of getting that previous answer is I could go second, hit the negative sign, and it types in ANS. ANS takes the previous answer and puts it into that spot. And then I could times that by 10. So that's one way of writing that out. A second way of writing that out using this calculator to its fullest potential would be 2 times 27 plus. Now if I use my up arrow key, do you see how it highlighted that previous number? If I go up and highlight that number and push enter, it'll type that number in for me completely. If I don't want to use the ANS key, that's another option for me. Then I can times that by 10, hit enter. I get my answer, which is 312.166. Now, I need to round that off. We want to round it off to the nearest tenth. We said a 10 has 1 0, which means we want to round it off to 1 decimal place. That second 6 right there, or that 6 right there, is the one that's going to tell us, do we round up or do we round off? And because 6 is 5 or greater, we're going to round it up. So our final surface area here is going to be 312.2, and this would just be units squared if we're writing out our answer on our test. Okay, next question here. This time we're looking at lateral area. Now here's the deal on this. We have a box situation again. My preference is, if it's a box, a rectangular prism, I'm going to use the top and the bottom as my bases. I'm just always going to fall back on that. Now, because you can choose if you want the front and the back to be the bases, left side or right side to be the bases, or top and bottom to be the bases, what I have when you go to type these answers into Moodle is I have all those answers calculated for you. So no matter which way you choose your bases, as long as you calculate your lateral area correctly, you should get your right answer there. So now as we do this, I'm going to use the top and the bottom as my bases. Lateral area is perimeter of the base times the height of my prism. So the perimeter of my base here would be 12, 4, 12, and 4. So I added 12 and 4 twice. So that gives me a perimeter of 32. Now my height of this, the distance from base to base, bases are the top and the bottom, so my height is the height as it appears on the object, which is 4. It's a normal standing object. So my lateral area on this would be 128. Oops, I put my little 2 in there a little too soon. And it would be square inches. Okay, another sample. Here we were trying to find the lateral area again. Our lateral area formula is the perimeter of the base times the height. So the perimeter of our base here, we have an 8 and a 5. It's a right triangle. We need the hypotenuse of that base. I know that the triangle is the base because the triangle is the non-rectangular side. Remember, the base, if there's non-rectangles, your base is the non-rectangle. So we got to find the perimeter of that triangle. We need this side right here, so we got to use the little Pythagorean theorem. A squared plus b squared equals c squared. That's 8 squared plus 5 squared equals c squared. 64 plus 25 is c squared. So that would be 89 equals c squared. And we would square root that. So our missing side there is square root 89, which is 9 point something. Okay, now so for our lateral area, we're going to calculate out our perimeter of our base. The perimeter of our base was 8 plus 5 plus the square root of 89. So that perimeter of the base is 22.43. Our height of this, because we're looking at a triangular prism and the bases are in the front and the back, our height is 10 because this triangular prism is laying down on its side. So our lateral area for this is going to be 224.3 units squared. Really, because I'm multiplying by 10, you just bump your decimal place one over. Don't really need a calculator for that. Just to double check and make sure I rounded correctly, we can type that in, taking a look at the larger decimal here, and it'd be 224.33. That second 3 tells us we're just going to drop the everything after your tens position, and we should be good to go. All right, moving on to cylinders. Find the radius of the base of the cylinder. Now this one is a little bit tougher than you might see in our regular geometry class, but I wanted to kind of throw it your way just because it's good for you guys to see these connections and see where the algebra does really come into play on these. So let's talk about this one real quick. They tell us this, we're going to do surface area. They tell us that the surface area is 100.5 square inches, and we have a height that is 6 inches. So if we start off with our surface area formula, that is 2 times the area of the base, so that's 2 pi r squared, plus the perimeter of the base, which is 2 pi r, times the height of the cylinder. Now let's plug in what we know. We know we have 100.5 for the surface area. We know we have 2 pi r squared. We do not know the radius yet. That's what we're trying to find. Plus 2 pi r times the height, which is 6. So if we plug everything in, we notice that we have a couple, we got a couple different radii there. We have one of them that's squared and one of them that's not squared. Now this is the look of a quadratic, which means you're going to have to use the quadratic formula on this one. Okay, and there's no way around it. That's just what's going to happen here. So we're just going to clean this up. We're going to take and we're going to find our A value, our B value, and our C value. We have to make this quadratic equal to 0 before we really get started. So let's clean this up a bit. So first thing I see here, we got 2 pi r squared plus, we can do the 2 times 6, which is 12 pi times the radius. That equals 100.5. Now we need to move the 105 over. So we would subtract 105 from both sides. And that gives us our A value, which is 2 times pi. And we're going to round that off. We're just going to go to 2 decimals right now. So we'll go 6.28. Our B value is right here, which would be 12 times pi, which is 37.7. And our C value, which is negative 100.5. Now, our quadratic formula, for those of you who have forgotten it, looks like this. X equals opposite B plus or minus the square root b squared minus 4ac all over 2a. So we're going to plug in our values. Opposite of b, that'd be negative 37.7 plus or minus the square root of 37.7 squared minus 4 times a, which was 6.28, times c, which was negative 100.5. And this is all divided by 2 times a, 2 times 6.28. So we're going to clean this up a little here. Go negative 37.7 plus or minus. I like to type all this into the calculator at one time just to get that value. So 37.7. Oops, wrong button. Oh, that's no good. Here we go. 37.7 squared minus 4 times 6.28 times negative 100.5. So I type it in exactly how it looks. I get my answer here, and that's 3,945.85 over 2 times 6.28, which is 12.56. So now we're going to do some more calculations here. We're going to take this and we're going to split it up. We're going to do one of them where it's adding, one of them where it's subtracting, and we'll see what our answers give us as a result. So pull up our calculator here. Come on. All right. So to move it over, we got negative 37.7. We'll go plus first. The square root of 3,945.85. We'll get that answer divided by 12.56. So we get an answer of 1.999 repeating, which is basically 2. So one of our answers is 2. The second answer, we take our calculator, we do the same calculations. Now notice I'm not going to waste time typing all this back in because I can use my up arrow key. I can go back up here. The only difference is I'm taking that and I'm going to subtract instead of add. So I'm going to go back and hit the subtraction key, get that answer. I'm going to divide by 12.56. That gives me an answer of negative 8. Now, because we're talking about a radius, it is impossible to have a radius that has a measure of negative 8. So the only one we would keep there is 2. So our radius on this problem is 2. I do not believe this type of problem will come up on your on the normal geometry exam, but it's a good problem for you guys to see and see the connections between the algebra and the geometry a little bit. Let's take a step back and do a little bit of an easier problem. So here we go. Here's a surface area problem. We're going to round to the nearest tenth. This should be a piece of cake compared to that last problem. So our surface area formula, 2 pi r squared plus 2 pi r times the height. So we're going to start to plug in our values. It'd be 2 pi times our radius. Now, notice here that's our diameter. So that means our radius has to be 6. So we're going to go 6 squared plus 2 pi times 6 times the height, which is 10. Now from here, it's just a simple calculator problem. We'll clear all that stuff out. 2 pi times 6 squared plus 2 pi times 6 times 10, and voila, 603.185. We're rounding the nearest tenth, so the 8 tells me I got to round this up, so my final answer would be 603.2. This would be squared inches, and we're golden from there. Notice here they don't have to give you the picture along with these problems. They may just describe it in terms here where you got the radius that's 12 inches, the height that's 14 inches. Start off with your formula. I highly, highly recommend, if not require, write out the formula every time. It just helps you to remember it, and it makes you more fluent. It doesn't hurt anything. Plus 2 pi r h. So our surface area here, 2 pi times 12 squared, and 2 pi 14 times the height. Oops, my bad. Fix that. The radius was 12. The height was 14. I can just move this over and make it a little cleaner. There we go. So now it's just a calculator problem from here. Two pi times 12 squared plus 2 pi times 12 times 14. Double check, 2 pi r squared, 2 pi r times the height. Calculate that out, you got 1960.4. And I already rounded that off. If you look back at the calculator, the 5 bumped the 3 up to a 4. And we're good to go on that one. Something to keep an eye on here, they're going to sneak in diameters every once in a while. If they give you a diameter, make sure you switch it to a radius. That's not a radius of 2. Silly. That's a radius of 3. So from here, it's the same situation. Surface area is 2 pi r squared plus 2 pi r times the height. Radius is 3 squared. 2 pi times 3 times the height, which is 12. Now, I'm going to throw out there, for instance, let's say they don't want that. They want you to leave it in terms of pi. They're allowed to ask you to do that, and I just want to show you what that means you would do here. So what I would do on that is you just calculate what this is without the pi. You calculate what this is without the pi. You just tack the pi at the end. 3 squared is 9. 9 times 2 is 18. So we end up with an 18 pi here. And here, 2 times 3 is 5. Or sorry, 2 times 3 is 6 last time I checked. 6 times 12 is 72. And now we go ahead and add up the 18 pi and the 72 pi. We treat the pi like we would a variable or any other variable like x, because actually pi is a variable. It's a Greek letter that means 3.14. It's just already defined as 3.14. It doesn't really change, but it's a letter that represents a number, so we treat it like we would if this was 18x plus 72x. Go ahead and add those up, and you get 90 pi, and that's your surface area. Now for Moodle, you would have to calculate what that is, round it to the nearest tenth, and type it in, but that's a good example of what you would do if you had something in terms of pi. I hope these problems helped you out for this homework assignment. I'm more than willing to we'll take some questions on this. If you have questions, you can email me, and I'll try to get back to you tonight. Otherwise, I can answer other questions tomorrow morning. All right? Have a good day. We'll talk to you soon.